Go.
Hello, everyone. Apparently we are live. So welcome to the 8th online meetup. I'm not sure if you see the crowd who has already joined us, because I don't see what the final output is. So I hope you see there are already a bunch of people who have joined. You can also join us. If you go to the vvvv website and look up the blog post where we announced this meetup, there are the contact coordinates for this Zoom call and a password to join us. And it would be nice if you all join us, because that allows for better discussions. Let's get right to it. Who do we see here? Natan Sinigaglia, the magician, tonight. I guess you're here to show something.
Yeah.
Yes. Just give us a topic so that we can refer to it.
No.
No topic. That's also a topic. Okay. No topic for Natan.
It means all topics.
The whole life.
Exactly.
And everything. Okay. Randall, what about you?
Oh, I'm just here for the free beer. Yeah.
Okay. Fair enough. Bastan also, I think, said already that he doesn't want to show anything today, but next time, he promised. Next time. We have Ingo. Say hello, Ingo.
Hello, everybody.
What are you going to show or talk about?
Doing something related to rabbit control.
Rabbit control, that's nice. Elias, what about you? Are you listening or talking?
I'm listening.
Great.
I wanted to, but I didn't have time.
Next time. You're already on the list for next time.
All right.
Chris?
Yeah, we wanted to give an update on views later when Kyle is joining. So I will probably give a bit information on the background, and Kyle will show some example patches.
Cool, cool, cool. And then we have Amir, and I think Amir is with Micheal, kind of together, and Darjia. Can you give us a brief topic of what we are going to hear from you?
Yeah, so Darjia, Micheal, Viktor, who will join us very quick, and myself, we are going to give an update of the output of one semester, the latest semester that I'm teaching vvvv Gamma at the University of Art and Design in Linz. And we made a really tiny thingy sort of application as a utility for fashion designers, and we are going to show what it is and what it does.
Okay, cool. Let's see, nobody else is joining so far, but you can join anytime. It would be nice to have, if you have any questions, just join us and we will let you in. So regarding the order of presentations, I am thinking now that actually I will start myself with a little demo that I have prepared together with Ingo. We want to talk about rabbit control. I'm not sure if I've actually shown rabbit control on a meetup, the latest version that works in Gamma. So I want to quickly do this, and I will, yeah, so 10 minutes roughly starting now. For this, I'm going to share my screen, and I'm assuming you see my screen now, where I have this example from the examples of that ship with vvvv nowadays. You assume this is my super big fancy project, and you know, the idea of rabbit control is that it allows me to quickly expose parameters so that I can control them with my mobile phone or from a web browser. So I want to briefly start this presentation by walking you through this process. So the way this works is we have to reference the VL.io RCP nugget. And then all we have to do is to create a rabbit and then say I want to expose the number of rings that I have here. So I would use an int parameter. Say this is going to be a value between 1 and 15 rings. And I just connect this here. Now they are gone because it got reset to 0. But really the idea is that I can now connect to using the Rabbit Control client that is running on this website. So I just go to this website and say connect to localhost port 10,000. And here I have that slider that gives me control to my visuals now. And let's say just as a second example, I'm using a float parameter to set the thickness of the torus. And this is going to be a value between 0 something and another 0 something. And you see I have the value here now. So by changing the slider, I can immediately control the thickness of the torus, and I can also put this float parameter inside of the loop, and then I get 3 sliders, and I can control them individually. So that's all basic RCP Rabbit Control features. As I change the number of rings here, you see I get additional sliders down there. And if I remove them, they will be removed automatically. So that's all the basics. But what if I want to control these parameters not only in my local Wi-Fi, but from the internet? So at the moment, I can go to my web browser. I can do this in my Wi-Fi on my mobile phone. But obviously, this is in a closed Wi-Fi. And Ingo has this idea of how we could make this work to have these parameters now exposed over the internet. So I will stop sharing and we will be listening.
I don't know if it's only me who doesn't hear Joreg very well, but
please go on.
Yes. So you probably guess what's coming now. Exactly answering the question: how could you control Rabbit Control parameters from the internet and not only from your local network? How you usually do that is by I prepared some slides. By the way, you will see my drawing skills. And my first slide is this one. It is the Zoom not liking this, so I need to get rid of my background filter. So, sliding in. What we saw right now is we have a local network, we have a Rabbit Control, we have an application, Rabbit Control enabled application, and we have one or many RCP clients controlling this application. So now, if you want to do this from somewhere else, of course, we have to do this over the internet. The internet starts exactly where the dotted line starts, and I slide this in, and this is basically what we want to have. This is something in the internet, and we can connect to it. So you see the two remote clients here. and what is called is rabbit hole. Why is it rabbit hole? You would usually do this by a kind of a cloud service. I have another slide for this. It's usually depicted like that. You have a cloud, you have something going in and out, but clouds are not nice places. It's cold and wet there. So we turn this around. And what we get by turning it around is basically, you already see it probably, we have a rabbit hole. So we want to walk through the rabbit hole. Another way of depicting this is it's from the wrong side kind of. So we have a rabbit walking through the rabbit hole, coming out of the other side. Yet another way to depict this, and then I think I'm done with my slides, is something like that. You have a rabbit sitting in front of a portal, leading it to somewhere completely different, and being able to control whatever it is from the other side, whatever that side is. So, Joreg, if you may open.
Yeah, that's totally clear now.
Yes,
that makes sense.
So we will show this how this works. It is a website, and you can access this website by entering the URL rabbithole.rabbitcontrol.cc. And you have this welcome page here. And what we just walk you through quickly, we just use it for now. There is something called a public tunnel. That is like, think of Jitsi or some chatting platform, just something you can quickly use and try out. So to use this, we need a tunnel name. The tunnel name has to have at least 4 characters to make it at least a little bit unique. Better to have unique names. The next thing we need to do is we have to copy out the tunnel endpoint. This is done by this button, the server URL. And you would use the server URL in a rabbit hole transporter with your rabbit control server. So, Joreg, do you have a rabbit hole transporter?
There is a rabbit hole here, and it takes a server URL. So I will just put this in what I copied. And then I would like to connect this to the rabbit, but it doesn't let me because it says here the transporter is a sequence of transporters. So for now, I will just make this a spread from value because I only have one transporter for now. But as I do this, oh wait, no, the way we wanted to do this is because this is now public. Anyone could now control my rings here, and I didn't want this to happen. We don't know what happens if now 200 people connect to this thing. So what I wanted to do is create a separate public connection where I only expose a read-only value. So for example, this this value here, the sign value. So, and I will set this to read-only, and this will be a minimum of -1 to 1 something. And I want to expose only this to the internet. Okay. So now I have done that. Ingo, what next?
Yeah, next you have to connect with a client to rabbithole, and that is done easily by opening the web client with that rabbithole name you entered. And let's see if everything works. We're waiting for the RCP connection, and there we go. We have a value which is the monitor value read-only. So you can, you could,
and this is now really public, so everyone.
So you can go to rabbithole, rabbitcontrol.cc, enter vvvv in the public channel, and you should see the same value.
Can we get some confirmation of someone that they tried this and just Is it happening? Is it doing anything?
I can confirm it works perfectly here in London.
Cool. So again, if I drag in this float parameter here into the loop, you should see a second value popping up.
It is there, yes.
Cool. Okay, but so let's. So this is public. It's not so useful. Probably it's super useful for a quick test, but for a real project, Ingo, we need something more private. How would we go about this?
There's a way to have private tunnels. Public tunnels are limited in the bandwidth and amount of connections possible. So to make a private tunnel, you need to log in. You have to sign up and log in to manage your tunnels on this website. You already have an account, very good. And if you go there, you see your tunnels. You have one. And
I have already created this before.
We've already created this before. There's one tunnel at the moment for everybody who signs up, and it's the same process. You copy out the server URL or the server endpoint and add it to your rabbithole transporter.
You see, this is now private. I shouldn't be showing this on the internet, but just so you see, this is a complicated GUID here, kind of, that connects, makes a unique connection. And now I have also shared this with Ingo before, so he now can control my rings, and that's kind of the demo. I didn't want every one of you be able to connect to this, but Ingo, are you controlling them? Yes.
Yeah, I already control
So
them.
you see, I have my hands up here, and the sliders are moving. I would attribute the jitter to my bad internet connection here. And here we have what happened.
Disconnected.
You did it, or?
No, I didn't.
No. But I guess that concludes the demo. Ingo, any final words?
It would be great. Yes, there's a couple of things to say. rabbithole is quite a young project, so it's kind of it works. It's there. I would be happy to get some feedback. Also, if it's something useful, and if you have any questions or problems with it, just come to the Rabbit Control chat and ask there. And if you want to know something more about it, just get in touch.
So where can people find the Rabbit chat you were just mentioning?
The Rabbit chat, you find it, it's on Matrix, and you find it on the Rabbit Control webpage. Joreg is showing it. rabbitcontrol.cc is the main page for Rabbit Control. We need to yet link the rabbithole there. And somewhere there is a contact button, and you can write us an email or connect over Mastodon or with the chat over Matrix.
And just to conclude this, you see we have already implementations for open frameworks, VVV, Open RNDR, and Touch Designer. So this is not a VVV only thing, it's an open protocol that anyone can use and that connects all these platforms. Okay. Any questions from the audience? I'll stop my screen share already.
Could I also use this from just standard C#? Can this connect to my C# program somehow without going through any of the before mentioned clients?
Yes. We have a GitHub where we have many implementations. What is it, like C#, C++, Ingo?
There's Java.
Java.
I think
TypeScript.
Yeah, but TypeScript, exactly. We have that's kind of the language implementations, and then we have a couple of integrations. Joreg showed it before, using those language implementations in open frameworks, open renderer, vvvv, etc., etc.
So how could I override a parameter from within vvvv? You have been showing like to expose it to the outside world and then control it from there with the clients. But is there also a way that you have been thinking of, like how could I now change that value, that particular value for all connected clients at the same time from that patch?
This is, you see, it's bidirectional. If I change the parameter here, you see,
yeah,
this changes for all connected clients. It's now not connected, but yeah. So
yeah, my sliders in my browser move. So
yeah,
because it's still connected.
So all the parameters are bidirectional.
What happens if I have multiple people sending different values to the same sink simultaneously? How does that work?
It's not particularly handled. It's just last takes precedence. There is no magic about this. Okay. So I'm thinking this might be the end of this. Thank you, Ingo, for this.
Thank you, Joreg, for this.
Thanking myself. And what shall we have a look at next? I was thinking, so is Viktor is joining, and Viktor is with Amir. Yes. So why don't the four of you show us what you've been up to?
With pleasure. Okay. So as we talked before, I think it was in November in the meetup. Yes, and then we mentioned that I have this luck and chance to teach vvvv in Linz at the University of Art and Design. And the semester that we just passed or finished, it was the third semester. For the second semester, I was using vvvv gamma. I think I remember the first semester, even there was no any stable release yet. So we were just having some fun time and complaining from the participant, or like sometimes I was like not sure what is happening and blah blah. But thankfully for the second semester, things were a bit more established and documented and stuff. And for the third one, I was thinking that actually it would be really good to just put this semester, define a goal for that, and going through learning vvvv gamma and also sort of basic concepts of programming, goal-oriented, like not just seeing and connecting nodes together and such. So with the students of Fashion and Technology department, it's very interesting because in this department, they are really very much thinking of designing utilities and applications that helps them to just get a bit more distance from a traditional fashion design more to like digital and using new technologies and applications. So what we have done was thinking of a setup that we have a projector that it projects a certain pattern on a table. You're standing next to this table, you see these patterns projected on the table, you lay your fabric on that table, you see all these patterns that you designed before, and then you have a laptop or a tablet in your hand, which is, there is a UI on there, and then you can just change the position, orientation, and you can manipulate the stuff that you see on the screen, on the table or on your fabric. So if it's a bit, what I'm trying to say is a bit more abstract and it's not really visualized, I just hand over to Darjia, one of the participants in this course, She's going to show, well, first of all, how is the traditional way and where we make a transition to our approach. There we go. I'm gonna go share the screen and hand over to, exactly. Give me a second. I should be able to share a screen. And the sound for later. There we go. Skip that one before this is spoiler. Yeah, I forgot to open one of this application. This is CLO. Okay, I hand over to Darjia.
Hi. So normally, when we have an idea, we design it in this program. We design a prototype, and next to the prototype, we have the 2D pattern. And that's the program where it's called CLO, where we normally design our prototypes. And so we can make, we can change the pattern, we can break it, we can do also sewing inside, and from here, normally then after we have the pattern, we print the pattern on paper, we plot it, cut it out, and then we put it on the fabric. And if we want to change something, we could, and we change it with hands, analog, or we have to go back to this program and to change it again and print it again. And the idea with this application was to mainly skip the part of printing and to directly project it on the fabric, and so we could change the position, how to cut it, and also we could maybe change the pattern directly in this application. Here is this application. We exported the files from the CLO program, but the prototypes, here you can see an additional basic t-shirt, and here is the menu, to the right. And this part, the normal, should be projected on the fabric. So, here we can turn it around, we can change the position. So, these are all the patterns. Just to simulate it once. Yes, and on a t-shirt, the next part, also the next steps will also be when we select the front part of the t-shirt from the 3D simulation, that it also lightens up the 2D pattern, which is normally projected on the fabric. And also we had a brainstorming in the class where we talked about what would be helpful in this application. For example, maybe to have this possibility to organize the pattern on the grain, or to add seam allowance, to change the, to draw directly maybe on the pattern, or also to to half the pattern, something like this. Yes, that's the main idea. I guess. It looks a bit weird. Yes.
Yeah, so thank you. That was, I think, a very, very good and brief walkthrough that what you can do with this application. So what is it, what we see right now here is actually, I mean, we call it in alpha. We have this application in like sort of the alpha version. One of the problems is that because of the pandemic and because university was closed, the whole lecture was was held online, so we couldn't really technically gather together and stand at this table where we see things projected on the table. So, but the idea is that, yeah, exactly, as Darjia said very well, the window below, the stride window that you see there is basically is on your tablet or on your computer that you have in your hand, and you just do all the interaction here. You can select different parts, and then you see the other menus. So the design will be different. So first of all, we will have customized the UI looking stuff, still using very well documented and very well designed Elementor, of course. And then there are, as Darjia also mentioned, that they are in the brainstorming phase. We had different ideas. So there are some different concepts when fashion designers, when they transfer a pattern on the fabric. So there are sort of complicated color coding and even the style of the lines. And also they have different packing ideas. Like think about it as this example in a Skia, that there's this packing algorithm that you put things like all the cubes or characters next to each other. But then there are other concepts that, for example, there is this grain of fabric. So you cannot just put a pattern there and just draw it or cut it. It has to align with the grain of the fabric. So we had this patch with one of the participants of the project. That he manipulated the packing algorithm in a Skia example, that all the elements or all the patterns that you see, they will be aligned to a line, that this line is in parallel to the grain of the fabric. So there are many small parts that they should be put together. And one of the reasons that I don't go through the patch is so messy, because and it's my fault, not the participants, because they did the job really great and I have to put all of them together. And soon, hopefully, when we have something that we can actually try it in university, when we are allowed to really gather together with the students, then perhaps we will release that so the others can also try that and they can report us their ideas and their feedback. So that was the part from our side. If you don't have any, if there is no particular question, I will have a transition to Michi and Viktor, which they were participating in the class, but they took one step further and they went with Elementor and made a UI for their robotic setup. I can show you the video. I have it on my computer, only if there is no particular question regarding to this very setup.
Do you hear me?
Yes, I do hear you.
So I wasn't quite sure if I understood what I saw. Am I correct in understanding? So this T-shirt we see there floating in space.
Mm-hmm.
This is in real life. We will have a real mannequin standing there, like a puppet, no? And there will be a projector on this puppet. Is this what's going to happen?
No. Do you want to explain?
I mean, it will project the pattern on a fabric which is laying on the table. But I guess for an artistic, it will be projected on a mannequin with a fabric on it.
Okay, so this is really only for better preview, how it will look in the end.
So the thing is, like nowadays, fashion designers, they design the cloth or the T-shirt, the very T-shirt that you are wearing in 3D, sort of, right?
Mm-hmm.
So they have these applications such as CLO and the others that they really design it on the mannequin, on a virtual mannequin, right? So everything is happening in 3D. But then when they want to cut this and they want to transfer it on a fabric, they have to make a transition from 3D to 2D. And then they make a flat of all these patterns and designs, and then they cut it on a fabric and they sew that together to get it back to actual physical three-dimensional clothes that you and I are wearing. So, and we are using an application for this transition between the 3D world and the 2D world in a real-time way. Because as Darjia mentioned, back then you had to export it in PDF or anything that afterwards you can use CAD and plot it on big papers. And if there's a mistake in that, you have to go back to your CAD design. You have to plot it again on the paper and bring it back, transfer it on the fabric. But here it's just real time.
Yeah.
In this case, you can change also on the tablet, and it's more sustainable. print it. You don't have to waste the paper, and also you don't have to even design a prototype digital first. We see how it would look, and then we see on the fabric, for example, how it would look on a special kind of pattern, and maybe we think, no, we don't like how it looks in this case, and we directly can change it. Yes. It's just a little bit of more sustainable workflow.
Yeah, and sustainable and quicker, no? In the end, because you're saving time.
And
right?
Students with no background in programming at all, they are the participant of this course, and that is the outcome. And I guess, I think I'm very happy with the outcome.
Yeah, wow.
I think it's amazing. I think it's amazing. And when I understand it correctly, in CLO, you basically designed the overall pattern, and then you have some sort of modifications that you do on top of that in vvvv while projecting out to the fabric, correct?
Exactly.
The parameters you control there with Elementor are, designerly thought parameters that might be interesting to try out with the design that comes from CLO. Is that correct? Yeah, okay, then I got it. It's cool.
Yeah,
That's
and then
cool.
there are other, like as we said, there are other features that they are not they are ready but not implemented in this very main patch. Like for example, one of the things that Darjia was working the whole semester on is that how basically you print a texture on your fabric, and before you design or you cut your fabric, you know that how this texture will look like in the end. So basically, you simulate that in V4 using different textures, moving it back and forth, and you know when the final product or the final garment is basically sewed together, how it will look like, even with like generative patterns and these textures that they don't have a beginning and an end. I think that would be it. I will move on. I'm sure that there will be more interesting stuff from Viktor and Michi. So I start by showing this video. I think it's basically on my local computer. So I guess there shouldn't be any. It should be smooth, I guess. Okay, so I guess I will stop sharing my screen, and Viktor and Michi, stage is yours.
Can you hear me?
Yes,
Okay.
we do.
All right.
Yes.
Yeah, sadly it was not so smooth, at least on my side. I don't know if the video was so smooth working on your side, but it's a technical issue more or less. I would like to share my screen and show you the interface that we built on the right side and give you some explanations so that you can understand what we were doing. First of all, let's share. So, yeah, so as mentioned before, Micheal and I are students at the art university. Micheal is on the fashions department, I'm on the media department. We started some while ago to work together on some projects, mainly working on robotics, trying to find ways to use robotics for production of garments. That's actually what we are working on. We're also in a research project when it comes to this. And after we did the course in V4 with Amir, we thought it would be cool if we can use it to create an interface, to have more interaction when it comes to the printing T-shirt that we're doing before. So just to understand the basics, we're using a robot at the moment and 3D printing technology, more like an extruder, to apply graphics on garments and other things. And because of some technical parts, we at the moment using one-line graphics. So we decided to build this user interface that you can see here. And there are some parts in there. It may be looking a little overloaded, but I'm still trying out a lot of things we can do with it. So first of all, I just go through some graphics. These are all SVG graphics, which can be scaled, which are prefabbed. So that's just graphics that we did or found somewhere and use for being able to apply it. In the end, you can scale it, you can place it. The square here would be more or less the face of the T-shirt where you can place it. There you can go through and look at the different designs and choose one. Then we have on the right side font generation where we are able to create some text down there. We're using VL Elementor as said, so let's just get it V4 comfortable. And there's some fonts you can choose. This is as well scalable and also rotatable, so that you can place it wherever you want. And then when you're happy with the graphic that you chose, let's say on an exhibition or stuff where this robot system is being used for printing on T-shirts for customers or something, you can press export. It creates an SVG data file, which I think I got here now. Yeah, so this is the output. The line size doesn't matter that much because the line size is one size at the moment. And this file is an SVG file that we put in Rhino, where we create the path for KUKA PLC that we can start the robot. So it's like the interface to work on this. Yeah. Yeah, I think that's more or less explained it, what this is about. There's some parts we're just trying out. You have some generative parts where you can create some graphics, really some tryouts now, where we just use some common things that we found on the V4 library. Then this is also Geos, where I create SVG graphics. Every time you press, it creates another kind of random form. This might be a little basic now, but we develop it further. And yeah, let's have one or two words on the moment at the limitations that I got right now. Things that I'm asking myself is, when I have a graphic like this and I can choose where it is, I have to, you see, I have a bounding here where I get it away, but I wanted that it's not able to be moved outside anymore. So I'm working on it still to be able to get some usability out of it. When you hover over it on the tablet, the keyboard pops up with the executor, and yeah, so just 1 second looking into the patch. It might be a little complicated, but you know, that's the beginning. And this is actually the left side control for VL Elementor we got here, the right side control, and this is the database that I'm going into, where I have this prefabricated SVG graphics which can be applied, and on the right side I have like the tool that I built for creating the font that I wanted to use. Yeah. And here down there is the more or less at the moment my place of experimentation, where I try to use some generative stuff. So it looks as crazy as it is. I can zoom in closer, but you know, a lot of patches we are using and trying out. And yeah, this is actually where it comes out in the end, the graphical layer rendering down here. And on the right side, it also goes in the SVG writer, which I use as the output at the moment. I think that explains it for the moment. Let's have some questions and talk about it, what we are doing. So I think I'm finished explaining. Hopefully it was understandable.
It's amazing.
Yeah, I think it's great. So you're saying you're using, it's essentially a 3D printer working in 2D in the end. You're outputting some sort of G code or something like this.
Yeah. Actually, Amir is also working on something where he tries to find a way to use V4 to work on KUKA PSC. To one day it might be able that there's not a step in between anymore.
Exactly.
When we put it into Rhino, then it will be able that we have everything in here and go right straight into the robot where we just produce this then. Yeah, and at the moment it's 2D, but we're developing the extruder tool further and trying to find ways to be able to work on 3D objects then. So as Joreg was mentioning before, it would be a vision of us to be able to have like a mannequin with a t-shirt on it, and to be able to use the 6 axes of the robot to be able to work all around on the t-shirt, so that you could have like a graphic design which is printed all around. We did a lot of tryouts and tests, and the material using is working fine. Totally. So it's quite interesting place to be, but yeah, it's a beginning. It must be developed further, and I'm sure there are things that I have to look in more to go on. Yeah, but it's cool to be able to do this with V4 because it was easy to get in and start to building, you know, when you took the one part and you start to take the next part, and so it grows, as you can see. There's many ways to do it. Yeah. Okay.
Have you thought about using embroidery? Like instead of having a 3D printing filament or whatever's ink or whatever's coming out of it, having like a sewing machine head on the thing and making like a nice little embroidered.
Yeah, we did some tests with a punch needle, and it also worked out pretty well and creates a very unique aesthetic. But we stick to the 3D print extruder because there are so many possibilities to create forms, print on it, or even to apply 3D structures on a textile. That's what really amazes us as well.
Yeah, and when the corona situation is getting better, we should hope to be able to show it somewhere once in a while, to be able to really use the system that we build on to make it available for customers one day. Yeah, but working with needles is also very interesting topic when it comes to robotics, and yeah, there's a lot of things you can try out with there. Yeah, so there's enough space to experiment. Also thinking it otherwise to move the mannequin and fix the printing device so that, you know, you get another aesthetic. You can also try to go with a 3D model to every place on the object. Then it's cool to be able to work on 3D objects.
Oh, thank you very much for this. I really like we see this transition now from people thinking in patches to thinking in applications, making little apps with vvvv and with the great Elementor UI library. It's super easy to mock up. It's really cool. And I lost a bit track of time, but I think we're good to move on. Thank you, Viktor, and thank you, Amir and Darjia and Micheal. And if I am not mistaken, we have 2 more presentations now. Is that correct? So we have Natan with the no topic thing, and then Christian with the Fuse update. No, we have Kevin who joined. Kevin, do you hear us?
I do hear you. Hi, how are you?
So Kevin also wanted to, nice to see you. He wanted to give us a rundown of the installation that you did, or a quick overview of what you did there? Yeah.
Yeah, absolutely.
So
and how VL works into it. Yeah.
Let's do that now before we then move on to Natan and Fuse. And I will set the timer for you for 10 minutes. Okay?
Sure. Sounds great. Okay. So,
cool. Yep.
Yeah. Really happy to be here. I'm presenting from Oakland, California. And this here is the website that my collaborator Alex Cruz and I worked on. So cloacaprojects.com, return.i, we were originally tasked to just make objects in the space, and it's a very digital duo. We were really pumped to actually make installation work, and then COVID happened, and here we are back in the digital space. So the project kind of came from that. You head to the URL, and there's a bunch of instructions on how to interact with the website, which really is, let me get this here, is multiple parts in that there is the objects within the space kind of mapped to this 3D key. So one thing that viewers can do is kind of see where things map on to here, kind of orient themselves to this physical space in this time of COVID where we're not allowed to go to art galleries. And then there's also a sonic component to this here. As you can hear, what is going on is a continuously running synthesizer. It's been going on since December 10, so it's an extremely long form composition. And in many ways, which on the hour, it is now 12 p.m., the sound randomizes to a completely different state to what it was previously. So we have 3 cameras in the space located at these spots. And then what is also happening is that people are able to control where these cameras are pointing toward in order to navigate, and then viewers' interactions with the website itself by clicking on different parts or by where their mouse is moving around is influencing the composition aspect of it. So this is going through, this is basically a live stream of these 3 cameras as going through this production computer here. The live stream is heading straight to Twitch. This is embedded into the background over here. You can play with the volume over here by clicking down there. The instructions are up on the top again if you want to play around again. But every click, every mouse movement, every click and drag manipulates the audio. And so this can be a piece that you stick in the background or something, and then someone might be interacting with the website from across the world, and you can actually hear the changes which go on. So I come from the background of a composer, so this is kind of, you know, the lens on that. The art pieces themselves are viewable here with kind of the key denoting where they are, and you can, as mentioned, point the camera to where they go. So what is going on here. On top of the embedded Twitch stream is an interface built using cables.gl, which allows for these controls. Cables.gl has a MQTT capability, which is how each individual user's input is being sent to the production computer, which is being put across into this the audio software, and also the manipulation of the cameras. So here, let's just take a look over here. So yeah, one way this works is that multiple people can be controlling this at the same time. You may, for example, want to take a look at camera 1 over here. So, you know, there's the relation of the camera, of the control, camera, of the control, camera, of the control over here. You may want to be, you know, zooming into here, for example. And with that motion, again, there's a correlation to what translates in the sound. But then another user might want to switch to another camera. So it's kind of this frustration of the viewing experience in the sense of how people interact. So this interface was designed to kind of go against the more slick VR-esque experiences, or the kind of Matterport experiences, which many museums and galleries are currently using. In terms of the aesthetic ground of why this is, you know, there's a lot of photographic apparatus here. There are little light boxes. There are umbrellas, which are evacuated of their use. You know, the umbrellas which shine diffuse light on various surfaces. It's kind of this play of a 3D world, but actually in real space with real control and optics, and the resolution of cameras being kind of a factor of things too. So in the sense of that, we are basing a lot of, like, this was kind of an inspiration here. So you can see that it was formed from this obsolete maritime flag here. So this would symbolize quarantine. If you were on a ship flying this, your ship is under quarantine. It's no longer in use, but that kind of formed the basis of what where this all goes. So in terms of VL Gamma, it functions as an intermediary between all of these things, connecting everything else to everything else. So the whole multi-purpose toolkit thing in play here, very happily. I come from using vvvv a lot, and learning VL Gamma has been really great. It's just extremely extensible, flexible, powerful, all those things that we like. And I hope people are able to visit this until it closes on February 28 and develop your own experience with this website and with the sound, with the composition, in terms of how you relate to a sonic work that continues over time. You can really just treat this as a synthesizer as well. So, you know, each of these are randomizations of specific parameters, and one part of this is where I'm coming from Oakland, as user ID number 492 is controlling a different set of audio parameters than someone else on the other side of the world. Or I may also want to change my user ID and change different audio parameters which I'm interfacing with. So yeah, enjoy. We are also doing a performance in the space. So, you know, again, further grounding that this is an installation in a small gallery in San Francisco, which is of interest to us. And yeah, that's my presentation. Thank you all.
Thank you, Kevin. Wow. I think I finally got a bit of a better understanding of what's going on, because you've posted this in the blog some time ago, and I went there and I didn't quite get what's going on. But now I got a bit of a better understanding. But I guess it's part of the idea to have this rather confusing and not really revealing
Exactly.
And so my understanding is that every visitor sees the same, right?
Every visitor sees the same thing.
Yeah.
Right.
And hears the same thing.
Exactly. They hear the same thing. I also want to point out there's a bibliography to this as well in some senses in terms of the conceptual basis of where we came from. So, you could very well be reading a PDF or something while you're it's kind of like a library or something that you could be held to this website, listening to this website, interacting with this website. And again, every kind of interaction you do reflects a change in the sonic content. And yeah.
Okay, cool. And it's all put together using MQTT. That's
exactly.
I understand. You're doing the interface here with cables. So cables is going to MQTT, and then MQTT is received by vvvv, which then sends some data to the synthesizer.
Exactly, and then everything's kind of broadcast out to the same viewing experience, the same shared viewing experience, and it's also a way to. As a musician, I haven't been able to collaborate with my fellow musicians, but this is philosophically a way to create music together. Right.
Cool.
Right.
Do we have any comments, any questions? So that was the 10 minutes timer. Do we have any other any of the panelists, any of tonight's panelists?
Is any of this being recorded, or is it like a one-off thing? So if I go in today and I hear something that was that moment in history, and never again will anyone be able to hear it?
It's pretty much the latter. I mean, it is being archived here in some form with these, 2-day long live stream videos in many senses. But one thing I'm also doing is capturing the recording, downloading it, and I have these huge 2-day recordings, one after the other, and I'm going to create a composition out of the moments where people have been interacting with websites. So as a composer, I'm kind of interested in, a piece made out of other people's data interactions. So there'll be various artifacts that come from this, but ultimately it's been a 3-month-long installation that will be gone after February 28th. Cool, thank you.
Nice. Thank you, Kevin. And I think we should then move on to probably now we have Kyle joined already, but I think we maybe go with Natan first. Natan, what do you think?
Yeah, let's do it. I can do it.
So this the stage is yours. I will give you 10 minutes.
Okay, no talking. I will share my screen. I told too much about this. I guess it's this one. Boom. Okay. Let me launch fresh gamma version. Let's see. Okay. Manage nugget. Come on back. And VL.Kairos.
What is it?
Let's see. So now I have a VL.Kairos library nugget I just installed. I'm gonna reference it. And this VL.Kairos library is a research that I've been doing since 3 years. Actively. And it's, well, it's a set of nodes and UI editors to facilitate, to create animations, to timeline things. So it's, let's, for example, create a timeline. So far, there is just a timeline. So we need an editor. So I have a node, I have a window here. I can select the timeline node, and I've got window. Okay, this is a timeline. Looks like. So this is my name, my parameter. And type would be a float. Yeah, simple float, simple float. New clip. Okay. I inserted a clip into our timeline, and this is the value. Let's say I move here, constant clip, I've got another value. And as you expect, moving the time, you see the output here. We have the interpolation. Then, what's special about this? It's just a stupid timeline. We can create a live value clip, for example. And there is a new pin popping up on the timeline, which is an input pin of float 32. So this means that I can generate from my patch, any way I want, a value that I feed there, and that value will be the value of this clip. So instead of this LFO, imagine having a sensor, like a Kinect sensor that tracks your hand, and depending on the Y position of your hand during the performance, for example, or I don't know, the installation, you can track people and use those into your composition, time composition. So you can feed values from the patch, and they are part of this narrative. Okay, you can build a narrative using live data because you are simply organizing over time. So you see, I'm coming from here, look at the output, I interpolate to the live value that I'm generating, and then going back to this other static one. So far, so good. Then we can also generate sampler clip. And a sampler clip, it's basically something that I can sample. So that I can ask a value. I give him a time. It's like a clip, no? It's like a clip that I can sample. Right? So there is a value provider region there, which is done for that reason. You can also implement this. You can create your own patch, your own class, and implement a certain interface so that you can build your entire world in there that will be sampled by this timeline. So, so here, for example, this is the thing that will be sampled when I'm hovering. In fact, if I connect an IO box, you see that probably you see the time there. The time that is the sampling time of the clip. So just to make an example, I can do, oops, so to float. Let's do it quickly. This goes to a simplex. Okay, plus let's offset these, and this will be our output. Now, what I'm using the time of the sampling to generate a value that is the output of this clip. Okay. Yeah. So this is the just to give you an idea. So there are different kind of clips with different natures. Constant ones, the one that we are used to work with in normal timelines, but there are also dynamic ones where we can feed data from the patch, from our software. There are sample clips, so we can create huge world that we sample when we need. Then there are, the interesting thing is that there's this timeline, but there is another canvas, which is this one, which is clip-based in the sense that I can organize clips and blend them on top of each other. Imagine like having a Premiere thing where you have clips and they get blended together on top of each other with different blending techniques. But now this clip generated an input which I can connect to my other timeline. So what it means is that I can compose these canvases, one inside the other, so they are nestable. So I can create huge compositions of different scenes. They might be generating data live, but still I can organize them, blend them together, timeline them together. Also in the timeline, I can create clips which somehow are entry points to other canvases. So it's quite, it's a universe, I would say. Let me see. Okay, this was a stupid overview, but it's way more than this. I just pushed the nuggets today. I still need to, to polish it and prepare air patches. I didn't have time, but just to give you an idea, you can have any type of channels, okay? So you can even have channels with entities. So you can even build 3D scenes that get interpolated if you provide certain interpolation method between your 3D scenes. Or you can organize them in a sequence, for example. You can really pass everything into these channels. You can define your own type and describe your own type, and then you can fit everything. And still you can have access to this interpolation method that comes with Kairos. So this is the idea. It's a set of tools. So today I released it. It's a nugget. This is the first version that I release. Actually, let me go here. This is my repository to do it properly. Let's just go here. Change visibility. Make it public. Let's just do it. Whatever. Okay, now it's open source. That's it. We have a nugget, open source. So let's talk about business now. No. So the idea is I can't say how much time I spent on this, honestly. 3 years. So, but I'd like to keep going because it's really just the beginning. There are so many.
I think that the first mention was during Node 17, was it?
Yes.
Node 17, I don't know when yes, that was so. Exactly in May, I think, no? So it's probably exactly 4 years.
Back then, I wasn't really working properly on it. Then a couple of years, 3 years ago, I got this residency. So I came to Berlin for this. This Kairos thing is the reason why I'm here in Berlin. So that's why, yeah, okay. But just to say, it's free for non-commercial projects. I'm trying to come up with a model to sustain this development. So it's totally free for non-commercial project. If you do a commercial project, you just contact me. Just to say that this is this temporary solution that I found to have this licensing thing, which is flexible, but just to get some money to continue the development. Then I'll probably go for it's another talk, but I want to share more detailed roadmap and I want to come up with a sort of workflow together to share this roadmap and share the financing of this development. So, but that's another topic. So for now, what I'd like to do is having feedbacks. What you will download now and try is already gone because in the last 6 days, I basically rewrote the softwares. But I couldn't manage to arrive to today with that software. So it will land probably in the next week. It's totally mental. But then we have a workshop in 2 weeks. I didn't announce it yet, but I talked already to David, and I can do a webinar about Kairos in mid-March. So we will come back to you with some details about it. And I hope, you have fun, honestly. I had fun and I learned VL basically doing this. So yeah, questions?
What took you so long,
cool.
Natan?
Elementa, actually. Yeah, because to do Kairos, I basically did Elementa, no? Because I'm stupid. So I could have done just a very specific UI. No, it took so long because it's not really, most of it, I would say, it's an intellectual research, trying to understand what's the problem, really. What you are looking, what do you want to do? That's the real problem. And because understanding the nature of the problem, it's already finding a solution, basically. It's pretty there. So that's why we went through, and that's why I rewrote the software in the last week, because to basically bring it to the next level in which everything fits together with the latest knowledge that I have about it. So it's really it's very philosophical, I would say. Really understanding what's the problem. So yeah, it took a lot, but I think that's where you learn to abstract, and then you got the simplest idea. Questions?
Christina has just joined us. Christina, do you have a question about this? Because you were asking the other day in the chat. Christina, can you hear us? Probably not. Christina? Nope, apparently she doesn't hear us. Anyone else with a quick question on this? I guess there will be questions coming up the next days. Is there any question in the chat maybe? Randall, can you probably check the chat?
I think people are just silent in awe at the magnitude of this release.
Yeah.
When's the workshop?
Yeah.
I don't know
just
yet.
Downloading it and trying.
We have to set a
Mid-March,
date and figure it out.
Yeah, we need to set up a date. And but yeah, I want to do it quick, so in a couple of days. In a couple of weeks. So yeah.
So where's the point where people should give first impression feedback? Whatever, forum, or where do you want?
Good point. I didn't thought about it. I will create a Kairos chat at this point for quick questions. Yeah, I will do that now.
And you will announce it in the vvvv chat.
Yes.
Or also in the YouTube.
So
comments.
you see here, I connected the other timeline where I did this basically into this other timeline. So a new channel got inserted. So I got also this clip from the other one in here. Yes, anyway, it's a workshop. There's a workshop for this. But yeah.
We have a question in the YouTube chat by Simone Marin asking, what kind of stability can we expect?
I don't guarantee any stability. What do you mean stability? There are some issues. That's why I need feedbacks. That's why I need people using it to face the issues and solve them. So what I can
you
say,
speak about
now,
like how has this been used so far?
Right. Sorry, guys. Just my mind is. I want to thank Schnelle Bundebilder the studio from Berlin, because they helped financing a bit, certain features and part of the development, because they use Kairos for the latest work that they are still doing, I guess. It's an installation here in Berlin. So, and that's a massive project. And I don't know, you should ask them. There are issues, and it's a new way to handle data and timeline things. So you never know, but they are using it in production now. So from my experience, well, I'm changing it constantly. So I never really, no, I used it for my residency program. And that was really good because it was quite stable. Once it's done, it's super solid, honestly. The main thing is the UI that I didn't really work much on the UI, which needs rework. And I would love, that's also the reason why I'm open sourcing and distributing like that, because I'd like people to join this development. I can't do it alone. I don't want to do it alone. So, but yeah. I would say just download it, play with it. Keep in mind that the version that you are downloading and playing now will totally change in a few days. But no, I mean, the concepts at least are those, and you can familiarize with them. Yeah.
Cool.
Natan?
Yeah.
Do you expect because you can show, maybe you can, I guess you can just delete the editor, right? That the UI is gone. So in my final application, I would not need the editor anymore because it's
well, of course, they're totally decoupled. Yeah, as you see, it's still running.
Yeah.
But there are so many things like, okay, this is one way to use a timeline. You create some channels, and then maybe you create the output pin for each channel. This is the very basic user that you can have, but there are way more advanced way to do it, to use this timeline, which is, for example, you can have your class, which is your, I don't know, your module with visuals, which has properties, as any class. And there is a node in Kairos, which is the binder, that takes care of connecting that class to any Kairos canvas. So that basically the Kairos canvas can have access to all the properties of your class, which is, I mean, probably it's an entire mode, could be an entire model, nested classes. So it's a tree. It could be your entire project could be accessible from Kairos, and then you can animate those parameters of your model. And this binder takes care of when you sample, when you playback, the binder sampled the timeline, the Kairos, and write back into your class. So you don't need to implement strange things into your patches. You can simply, having this binder, you can establish a connection and animate your world within the Kairos world. This is one way, or you can, with other nodes, you can simply sample a channel. You type the name of the channel you're interested, and you provide a time, and you get the value out of it. So there are many ways. But as I said, it's quite vast, and we will have one workshop. I don't know, it will be 3 hours, I guess, just for entering into this topic and have an understanding. Then probably we'll do another one maybe later for more advanced users that they maybe want to have a more, they want to get into the actual library development. So yeah.
Yeah, I hope we can convince Schnelle Bunte to show us the project's timeline when it's done. So that should also give a good idea of how this is used in a real world project.
So just question.
Thank you so much. There is a question.
No, just a question. You said you're going to hold a workshop in a few weeks or something, or?
Couple of weeks, I would say.
Couple of weeks. And it will be, how will it be communicated? I think it will be good to hear, because some people like me, which are not so into it at the moment, like to know how to get into it, get to the workshop early, you know.
I think there's two connection points. The one is, of course, vvvv.org. Make sure to get everything there. And the other one would be the Node Institute channels. And there you will find it.
All right, thank you. Just to state it, it's good to think so that people which watch this also know how to get it there. And I'm also interested in it too.
Good, good.
Thank you so much, Natan, for all you put
My
into
child,
this.
for you.
Proud
Amazing.
mother. Well done.
Cheers to that. Cheers to that. So, last but not least, we have Chris and Kyle joining us from the Fuse Labs.
Yeah.
And we're getting some update of their work on the Fuse GPU tools. I don't know who of you will be sharing the screen.
Yeah, I guess.
Please just.
Yeah, I guess I will start showing like some basic stuff, and then Kyle will probably take over and show some more advanced patches that he already did. Yeah, so let me share my screen. Yep. Yeah, so here you see a basic patch. And I guess it's like from one research project to the other. So I was really like excited, like I said last time, probably when we announced it. I was really excited about shaderfx and the possibilities of VL, and yeah, I was really happy to dive into it. Yeah, now we kind of started to build a system around it. And this is like one basic patch, just to show you what's going on. Like this is a patch, this is a visual output. And as shader, or as Fuse is about working with the GPU, we also have a shader. And this is what you see here. And so basically what we are doing is we are generating shader code on the fly while we are patching. So like, this is probably what you know from Stride. There's a mesh renderer, and this one gets an effect, and this effect is now created from Fuse. And as I take this one here out, you see that the shader is automatically recompiled. Yeah, we have a default shader where just red is put out, and this is what we see. And so if I patch this back in, shader gets compiled, and then I have everything in here, and it is drawn. And yeah, this is probably just really a short lookup, you know, so that you get where we are staying, where we're at. So really like a topic is like, how do you patch stuff? And this is a lot of experimenting, like what is a cool way to patch? What are possibilities? And there are already shader graphs and other engines, but of course, like in VL, we want to get a step deeper into it. And so this is a lot of experimenting. Just quickly to show you like what is going on here. Like here we have a basic VL stuff, like simplex noises, where I animate some values. And then those values like get over this GPU stuff into the shader. Then I have some shader variables like texture chords, or also the position. And this is then all fed in here. And then we have different kind of nodes, which are all in GPU land. And yeah, so of course, like one thing we started with is generate noise, and we have some FBM, and this was getting us started. And one later feature that we just added is like we also have a preview node now, like a tooltip, so that whenever possible, you can look into the data that is generated at this point. So like here, you can also just look into the XY coordinate channels, which get out of the texture chords. And Another feature that we have language-wise is that it is possible to generate like function pointers, so kind of like delegates that you can pass over to the shader. Like for example, here the FBM node is receiving a noise as a kind of function, which is then evaluated and put out. To like maybe show you a short way how this is done. Like this is, for example, a way like how you would patch like such a delegate. Like you pass over a function over here, which can then be called. And here you can say which function I want to use. So this is basically I pass over the plus or the minus operator, but this is probably going too deep now. Just maybe show you another demo. Let's see. Yeah, this is this. So currently we are in the state where we have basically the draw shader working. So you can manipulate the vertex output and the pixel output, which is what you see here. We kind of starting with compute shaders. Yeah, and we have like already a big kind of library, like if we're going through the categories. So it's like basically all the intrinsic HLSL functions are there, like all the math and stuff. There are some color operations, like blend modes and color space conversions. Yeah, there's some noise stuff, which is where Kyle will probably talk about. Yeah, a lot of dynamic operators and different ways of how to work with shader code itself. So for example, like here, when I generated those colors, they come out of a shader function. So basically, this is where I call the function, and it comes from from shader toy, like the big resource. And like the idea is also like to get all of these kind of knowledge and stuff and functions and ideas which are here as snippets into the toolchain, kind of ordered and make it more accessible or also to people without shader knowledge. Yeah, that's so far like to the introduction. Maybe later when there are questions, and then I would head over to Kyle.
Yeah, cool. Just give me 1 second. I'll set up screen share here. Yeah, so I was going to talk a little bit more just about kind of the noise primitive that we've been prototyping. As Chris was saying, we're still kind of like in a early stage of the project of figuring out how like a lot of the machinery that drives it should work and how the workflow should be. But I thought this would be kind of cool to just show like already some early fruits, I suppose, from that research. It's kind of deceptively simple. We've got this one noise node, but I'm just gonna kind of take you through this patch and explain a little bit. Yeah, I guess how it's similar to the nodes that existed before, but also how it goes a bit beyond. So there's these kind of different like basis types, which are just different signals, and that's what you can see on the screen at the moment. You can see that output on the screen share, yeah. It might be the frame rate's a bit low because streaming from Australia, but it's nice and silky smooth on this end. So we've got these different basis types, and this noise node is basically a wrapper for them. So it's providing like an interface where you can switch between them. So this subpatch is basically the one we're seeing the output from now. So, you know, I can select which kind of function I have. Has some kind of general controls that you would expect to have on noise, you know, scaling the frequency or the amplitude or all this sort of thing. What's really interesting though is that I guess like in Field Trip or something like that, it was very type specific. You know, it was dealing with 2D and 3D noise, and a Sealer, scalar, vector fields. So there was basically 4 types, and that's all you could do. And if occasionally you needed another type, you were basically just out of luck. You had to build it yourself. With this one, it's a little bit different. We've got actually, it supports kind of domain in 1D to 4D and a result in 1D to 4D as well. And if that sounds a little bit weird, don't worry. Like I'll kind of explain it in the next couple little sub patches. But it's really powerful. It basically means that if you've got like these basis functions, it's adaptive. So it just pays attention to what it's connected to and uses the right function accordingly. So if we have a look at like the domain types. So here in this patch, we're actually using the same type of basis noise. So I think it's a simplex or a gradient noise. This patch probably has a little bit more spaghetti in it just because it's doing quite different things in parallel. But yeah, so here you can see I've got actually the same settings for these noises. And it's the same node again and again that I've put in parallel here with the same inputs. The only difference we have is where the domain is coming from. And by domain, I mean like the position input, basically. So, you know, you've got like, if we look at it from left to right here, and it kind of follows the output there as well. Here on the first one, we're taking the texture coordinates and we're taking just the X coordinate of that. And then it kind of knows to make a 1D noise from that. 1D noise is actually really easy to underestimate. You can use it for lots of cool things. If you think about maybe taking a distance function for something and then using the noise on that. But anyway, I won't get on too much of a tangent. I put this 1D plus here as well. And that's actually 2D noise, but it's basically we're taking kind of that X coordinate of the texture coordinate still, and then we're joining that up with just like an LFO, basically like a timer. And so that's how you kind of get animated noise, basically. And from kind of Field Trip and Instance Noodles and the noise things I've done in beta, actually the single most kind of requested feature was like, you know, how do we animate the 3D noise? And the answer to that is to use 4D noise. But it didn't exist before, and now it does. It's implemented with every single type. So you can see this is 2D. This one here is 3D, animating the 2D. That's that 2D plus. And then the last couple here are actually ray marched. I might kind of show it. It's not very beautiful, but it's just like for demo purposes. But you can see the last one's actually animated, and it's not just a case of like scrolling the domain or something. It's animated in the time domain. So that's actually 4D noise on the end there. You can see also here, like it's kind of interesting. Most of these noises are plugged straight into an input. For the 2 ray marching examples, it's kind of where it also gets interesting into this kind of delegate system that for the first ray marching example, I've got this pin here that's just letting it know that it's kind of in 3D space that it has to deal with. But otherwise, there's not actually an input there. There's nothing going into it. And so what's happening is it's basically just deferring that parameter to like basically later the ray marching node will provide it with that input. So it's just kind of waiting till it gets it later. And that's quite powerful to be able to do. On the animated one, I've got this delegate parameter override one, and basically what that's doing is it's the same thing as this. And if we looked inside here, you'd find one of these, which is allowing that to kind of wait before it gets the input. But by making the node again here, I'm actually basically taking now the input that it's going to have later and doing some things with it. So like I'm just basically adding that time dimension in the fourth dimension, and then feeding that in. So even though the noise is only providing kind of an XYZ, or even though the ray marcher is providing an XYZ, sorry, the noise is actually taking that from the ray marcher, adding an extra dimension, and then returning like a value back to get that animated noise. So yeah, again, this is all with the single node, which is pretty cool. So I mean, that was all the domain types. That's this domain 1D to 4D. If we go to the next sub patch, then we can see about return types. And this is probably what people think about a little bit more intuitively when you talk about like vector noise or things like that. It's more about the return value that you get. So you can see the one on the left is just like a single channel. The middle one is 2 channels. I mean, here we're just kind of displaying it quite literally, so we get the red green. And this one's like a 3D result. I mean, here I'm just showing them as textures, but the nice thing about this node and the system we're making in general is that it's completely abstracted from how you actually use it. So we're going to be able to use this same node in compute shaders and materials and particle systems and ray marching. You can really apply it everywhere, which I think is really nice. It makes things more modular, but also like when you really learn how to use a particular node like this, you can then apply it to all of those different domains. Have a quick peek back in here. This kind of repeated GPU in from float, you can think of it a little bit like the kind of dynamic buffer nodes. It is a bit of a pain at the moment, and I'll just say like it's something that we're kind of actively working on. But yeah, it kind of makes a lot more in the patch than there needs to be at the moment. So yeah, I mean, you can see with this one here, we've just got the texture coordinates only. I think there's this offset parameter that's kind of making the little bit of movement. And this basically have all of the same settings. The only difference we've got is what they're connected to. If I was actually using the same kind of noise, I could just do all of this with one. The reason I've got it in parallel is it's actually under the hood doing quite different things. So each of these is calling a different version of it internally, basically. This cast float node is basically just doing like an automatic swizzling. So I mean, you know, this is a 1D result, a 2D result, and a 3D result. You can see on the little tooltip preview there. I'll just make it a bit bigger as well. And so it's just kind of swizzling that into a vector 4D, which is what the pixel function expects. You can even see here, if I go on this, I've got like a spread of textures coming out there. It's pretty cool. So yeah, I mean, this next patch we're looking at is actually going to be a slightly different node. So these kind of basic types of noise, they don't really need an extra parameter. Obviously, there's useful things like frequency and amplitude that you want to do with them. But that's kind of what this noise node handles. And because they all have like a common interface, it's just convenient to be able to control them from the one. It's quite easy if we want to add more. But there's some more kind of particular noise types that then sort of deserve their own things. So we'll have a quick look at some cellular noise as well. So yeah, I mean, this is kind of quite like a literal display of it as well. So you can you can make it look much more beautiful, but I guess it's more of a technical demo. But there's some quite nice things. Again, this isn't kind of necessarily like new state of the art or something. You can find all of these on Shader Toy, but it's very like balkanized. Like you have kind of disparate functions and knowledge around. So we're really trying to just distill it and make it all very accessible. So, I mean, this is kind of like the typical sort of cellular noise up at the top, and there's like a bunch of different distance metrics you can use. Internally in the node here, we can have a quick look inside. You don't kind of need to worry about this so much, but what's interesting is that it has like this distance metrics as a module, so we can use that same module elsewhere, anywhere that we need to do distance calculations, and have access to those as metrics as well. As well as kind of the normal noise, there's some neat things you can do that wasn't necessarily very easy to do previously, where you know, we might have a module or even a shader function specifically that has multiple outputs. So like with this bottom row, for example, there's a couple of things going on. The cell position and cell ID is basically like it's a way, if you wanted, for example, to sample over that whole area just where the position of the cell is, if you ran another noise through that or use that as the domain for another noise, you could have like a terraced landscape or things like that. And the smooth cell ID is just basically giving like a unique value for each of the cells. I think a couple of these are on running on a smooth one. It's got like it'll look at like a bit like a blur in the texture, but it's actually working kind of at the function level. So you can see if I turn this up, we kind of get it convolved a little bit. And that's quite useful for like a lot of shading and things if you don't want to have these kind of sharp edges or discontinuities. It can be really nice to have that. Oh, look how I spelled correct. That is not correct. Correct edge distance. Correct. Yeah, it's kind of another version again, like if you really want a clean kind of edge between them. There's this traditional way of doing that, like F1 minus F2 or F2 minus F1 or something that almost gets it, but doesn't really work, but this gives a kind of precise distance. Yeah, and then moving on, the last one, there's not really too much to explain about it, but I just kind of wanted to show like a more kind of complex noise made with these nodes, just because the other examples are very kind of elementary, I suppose. So yeah, I guess the shading's not anything exciting, but that'll have a kind of very interesting modular ray marching system in process, and hope to have nice kind of PBR and lighting and shadows and everything like that. But you can see still as a visualization of the function that you can use these nodes to make much more complex things as well. Yeah.
Wow. Just wow. I think it really shows some amazing progress from just last month. Wow. Any questions from the audience? Any questions from the chat? Any questions from the panelists? Again, it's, I guess, something that needs to sink in with everyone. Meanwhile, Kyle, so we should reiterate that this is a community funded project, and you should probably repeat how people can support this development. Maybe you can even show the web browser and go to the store to show people where they can actually directly just.
Good idea. You would think I would be better prepared for this, but I'm literally watching the sunrise right now. So yeah, just like on that level, I actually should have kind of led with a huge thank you, because we've had like really amazing kind of level of support, both from studios and for individuals that have kind of supported the project already. And yeah, it's very kind of touching and honoring that people would give us such a degree of trust. So I would say thank you for that. And yeah, just like to be a little bit patient with us as well. We're trying to do it really properly. It might take a little while, but yeah, I think it's a good endeavor. If you do want to support it, you absolutely can. And I'm kind of just trying to find the link now. Does anyone else have any of that stuff handy at all?
It should be just store.vvv.org.
Yeah. So like, I think.
Chat.
Ah, thanks. Cool. So yeah, I mean, basically, there's a couple things you can do. You can donate a financial amount that is very helpful. There's basically 3 of us working really hard on this. So that's a huge help. And you can also, there's like a form if you want to just register interest for helping out in other ways. I think at the moment we're kind of like a little bit focused as a smaller team on it, but in kind of stage 2 and stage 3, we've got a lot of plans to like workshop people with how the whole workflow works, and to kind of have a larger collective work on things like documentation and testing and even library expansion. You know, there's a lot of stuff that is kind of already existing in beta that we can just port to the new system. It doesn't necessarily need to be redesigned or something. So there's, yeah, also, where do I get it? Someone's asking. It is actually on GitHub already. I think we're not really at a point of like making a release or being ready to support it. So if you kind of are just curious and wanting to have a look, or you're wanting to kind of actively participate in development somehow, definitely check that out. But as far as like something that you can download and have a try, I would just say stay tuned. It's not quite there yet, but it will be.
Okay. Did meanwhile any more specific questions come up? Doesn't seem so. In the chat, we have one guy saying, I think I should donate, kind of long overdue. Yes, you should. Thanks for joining us. Automaton. So you got one more signed up here, it seems. I don't know, any final words? Randall?
I'm speechless. So many things happening today. It's like Christmas all over again. This is crazy, man. Amazing work, everyone. I mean, yeah, hats off. Incredible stuff.
Yeah, so maybe like one next step, we're currently looking into regions, also with the support of the vvvv devs. So this is like also really encouraging, I have to say. Like it's a close collaboration. And yeah, we're really hoping like to get some more nice workflows then with really tighter integration into the whole VL system. And then maybe also like see, yeah, well, where this might help in other topics as well. Yeah.
How are you handling documentation, and are you thinking about like the educational aspect of it and how you will go about that?
Well, yeah.
We have been thinking about it a bit. In terms of like planning and stuff, we haven't done too much yet, but that's kind of fitting in with the larger timeline and plans. It's kind of like the phase that we're in still now is a little bit more like the deeper research, I suppose. And as we get to kind of the next couple phases, it will be more and more about the kind of context of how it fits in with with like users and the ecosystem and things like that. But yeah, I think definitely the idea or the concept behind it is that when it actually gets to the point of like the first proper release, that there should already be like a decent wider pool of people who are actually already familiar, not just with how to use it, but even how to make modules for it, how to make the documentation in a format that kind of is consistent. And yeah, that's the plan basically.
Cool. Person, you've been watching quietly for 2 hours now. Any thoughts on what you saw tonight?
No, well, tonight was great actually, really. Especially the timeline looks great. Fuse is coming together nicely. We're really looking forward to see the final product, to be honest.
Yeah.
Do you think we maybe get some T-shirts for next node by Viktor and their fancy robot arm? That would be nice.
Yeah, that sounds good.
Yeah, but the fun is in showing it in front of people. So, you know, COVID is not our colleague now, you know.
Yeah. Cool. So I think the problem is we still have to stay on because David left, and David is the one who has control over the stream. Or Randall, can you also stop us?
I think so.
I have a leave button, but I don't know if that's enough. Yeah, no, I don't see anything here that suggests.
Seems also my internet connection is going in and out. Yeah, I'm not sure if we can stop this thing. So we have to wait for David to come back.
Do you have your saxophone with you, Natan?
I don't, man.
Ah.
Yeah, unfortunately.
Maybe Automaton wants to visuals there that he's sending us. Is there anything you want to comment? Then say it out loud. He doesn't have a camera, but maybe you have a microphone. But no pressure, you don't have to. Then turn off the stream later. Amir is coming back. Amir, do you have an are you a co-host?
I'm not actually. I was just checking if I can do that because
but
it
no
was
pressure, you don't have to.
I'm just looking to the links. What about Natan?
Amir is coming back. Now we have a feedback loop going on somehow. Yeah, do you have an
Just a second.
So Amir was made a co-host in the beginning, and
yes,
he might be able to.
David is coming.
Kill us. David is coming.
There's
David.
the man.
David.
No! We are trapped.
Oh no.
Natan, do you want to tell us again what you have been working on?
Yes,
There it is.
David,
yeah.
we're waiting for you.
So good to see you, David.
We've been killing time now.
Sorry.
So just
pull the cable.
Pull the cable.
We're
We said everything for tonight.
Okay. Then I will pull the cable. Huh?
Yes.
Thank you very much.
Thank
See you soon.
everybody.
Have a good time, guys. Ciao.
Bye.
Yeah.